afternoon, everyone. Welcome to yet another lecture of web-based decision support system for business decisions and practitioners. This is the continuation of the previous lecture, and we were talking about details. We are delving into the details of database management system (DBMS). Specifically, why the database management system is important to decision support system and what does it entail to. We have already seen that part, and we have also talked about some of the basic aspects of how the DBMS technology evolved, how the relational database systems, internet or HTML based database systems, object oriented database systems, all those things have been discussed in the previous class. And today we are getting into what we call as the concepts and architecture. We are going to get into the nitty-gritty details of how to get into the design of the database. Okay. And this is important because if you do not have, so the philosophy here we are going to do is GIGO, okay, garbage in, garbage out. Okay. So, if you store garbage data, then you will get garbage results output. So, it is very critical that we store the correct data, and today's presentation is all about discussion on what is data models, what is schemas, instances, and the three schema architecture that typically is used in the DSS systems. DSS systems use this commonly. Okay. So, that part, and then we also little bit a quick introduction on database languages, and this will cover the background and allow us to move forward to the advanced topics and getting into ER diagram, etc. So, without further delay, let us see some of the fundamentals. Okay. Remember, the focal point is DSS, and that too is corporate, okay, or business DSS. We are not talking about other DSS per se. So, the first one is we talk about something called as a data model, a concept called data model, or what is data model. A lot of people in the DSS business, you will say that we are working on the data model. So, what is a data model? Okay. So, this for us is in a simple terms, it is concepts to describe the structure of the database, the structure of the database. Okay. When some people call it as DB, they are referring to database, and a set of constraints that the DB should obey. Okay. So, that is what we call as the data model. So, it describes the structure of the database, okay, how the database will be like, okay, what will be the major table. So, this will include the tables, okay, data that goes into the table, etc. And the constraints, like constraints includes what is the unique identifier, okay, relational keys, etc. We will talk about what relational keys and etc. in the later thing. So, when you take the structure of the database and the set of constraints that the database should obey, that completely both of them put together gives you the data model. Okay. Then comes the second term, which is called as the data model operations. Okay. So, what is that? Okay. So, this is the operations for specifying database retrievals and updates by using the concepts of the data model. Okay. So, what we are saying here is operations or specific computer instructions that specifies how the database retrievals and updates. How do you retrievals means extract information or data from the database, okay, or updates include add new data, okay, modify existing data, okay, remove some data, etc. Okay. So, all these things are aspects of what we call as the updates. Okay. You can add new data, you can modify it. The database contains the latest information, but how do you do all these? How do you do the retrievals and updates? You have to use the concepts of the data model. Okay. So, the data model concepts, whatever be the structure of the database and constraints, you use them and do not violate them to make sure that the retrievals and updates of the data happens. So, such operations are called as data model operations. Okay. And typically this data model what we talked about, okay, they are divided into three, broadly into three. There are many things, but for the DSS, okay, for DSS aspects, okay, we can take these three broad classifications. And the first one, the primary one, is what we call as the conceptual data model. Okay. This is what primarily we will look into, okay, and this is also important to us, and this is what the designer really focuses on. Okay. It is also known as the high level, or some people also call it as a semantic model. There are yet another name, or entity based data model. Okay, entity based data model. So, there are its conceptual data model is sometimes people called as a high level model. Okay, it is in the designer level, it is mostly done by what human beings are. It is also called as a semantic model, or it can also be called as a entity based data model. Okay. So, what does it do? What is the main purpose of it? Okay. This provides concepts on the perception of the user. Okay. Whoever be the user or whoever be the person who creates the data, how do they perceive, okay, the data, and their concepts on that data, or how they perceive that data concept, is what actually is captured in this conceptual data model. Okay. That is the first one. Second one is the physical data model. Physical data model. Okay. So, this also has other names, other many books and people call this also known as, or also called as, okay, low level model. That is other name for it. It is also known as internal data model. Okay. Even though people rarely call the conceptual data model external, but the physical data model is also known as the internal data model. And what does it do? Okay. It provides concepts on the data storage about the data storage. Where is this data storage happen? In the computer, or you can think about it as, or server, or whatever you want to call it. Okay. Server is also a computer, right. So, the aim of the physical data model is to give you idea or concepts about how the data is being stored in a computer or a computer server. That is the second aspect of it. Okay. And then the third one, the third model is what we call as the implementation data model. Implementation data model. Okay. These are the three major aspects from our name. Okay. There is another name for it. Okay. Also called as, or also known as, the representational data model, representational data model. Okay. Not too many names for it, mostly known as representational data models. So, what does it do? Okay. It provides, what does it provides? Intermediate blend, okay, of blend between physical and conceptual models. Okay. So, what the idea here is that the physical conceptual model is, this is in the human, okay, the mind of the human. The physical model is in the computer. Okay. So, the implementation data model is the one that actually translates from the. So, what it does is this human to computer translation, the implementation data model is the intermediary in between it. Okay. It provides you ways to translate, okay, the intermediate translate or intermediate blend, what we want to call it, between the physical and conceptual model. Hopefully, this is clear. So, we move to the second concept or second aspect, what we call as database schema. Okay. So, there are so many definitions to this, but the simplest definition, okay, definition for us from a, let us take it from a definition from a DSS standpoint or viewpoint. Okay. We are going to define it from the DSS viewpoint. It is the, we can say that schema is the description of the database, is simply the description of the database, is the description of the database. Okay. So, when you describe it, describe the database, what does it includes? It includes two things. Number one, okay, structure, and two, constraints. Okay, structure of the database and constraint of the database. Okay. So, these are the two aspects. So, you can display, you can do it in many ways. So, this is the first aspect. Second aspect is diagrammatic display of schema is known as schema diagram. Okay. So, one way to think about it is schema can give you the description of the data. So, sometimes let us say if there is a table in the database, okay, let us say like this, and you give the, like for example, there is a table like name, okay, or personal details. So, you have first name, last name, date of birth or something like this, and you have Ram, Krishna, Tom, Moody, etc., right, and some date of birth like 1/1/2022, 30/1/12/1967, something like this, right. So, if you look into this, you can say some stuff like F name is alphanumeric, okay, both F name, and same is true with L name also, last name also. DOB is date in DDMM YYYY format, etc., right. So, you can do this, okay, and this, some of them are the description, the structure, okay, this is how it is, and some of them are the constraints. You can also do the same thing in a fashion like this, okay, F name, L name, DOB, MNDDYY, something like this. Okay. If you do this and you call it as personal details, something like this, this diagrammatic representation of what you just talked about, the structure and the constraint of the database, is also known as the schema diagram, right. Then another aspect of it is component or an object, component or an object within a schema is known as schema construct. So, if somebody says that I am working on a schema construct, what they are doing is they are either talking about one particular component or an object within the schema. Okay. It can be a row, it can be a column, they are talking about some specific aspect of the schema. Okay. So, then you should remember this point also, the actual data that is stored in the database at a particular moment of time, okay, is the database instance. Okay. So, some people call, there is a word called database instance. Lot of the time people confuses this with schema construct, it is not. Okay. When somebody says database instance, it is the actual data stored in a database, the actual data stored in a database at a particular moment of time. Okay. Particular moment of time, okay, is the actual data that is stored in a database at a particular moment of time. So, the instance can vary. So, which implies what? Database instance can vary according to the time. Okay. So, if you say on 25th of Jan 2023 at 6 a.m. what was the content of the database, and at 26th January 2023 at 4 p.m. Okay. Both these times the database will have, this will be an instance 1 and this would be an instance 2. Okay. There will be some changes, some modification of the database. Okay. Database instances, okay, they are also known as, there are other names for this, okay, known as state of the database. Okay. Or there is another name for it, it is also known as the occurrence of the database. Okay. So, somebody is a state of the database or occurrence of the database, they are all talking about a database instant. So, remember database instant, as we said earlier, the schema construct, okay, that means it is a specific component or something of the database or of the schema, whereas the database instance is the whole collection, the actual data that is stored, the entire data that is stored in the database at a given moment of time or a particular instance of time, moment or instance of time. Okay. That is what it is. So, now without delaying, let us go to the 3 schema architecture. Okay. This is the most popular architecture. There are other architecture also, architecture followed in DSS, okay, corporate DSS, that or business DSS, the 3 schema architecture is actually followed. Okay. So, the main aspect of it is, okay, you have, okay, let me call it as, okay, these are the end users, end user 1, end user I, end user n. Okay. There are n end users, right, and each end user will have a external view, okay, for this particular end user. Here is another external view. Okay. Whatever they see, external view I, let us call it as, okay, external view n. Okay. They can be the same, they can be different also. okay, does not matter. Okay. So, this is the external level or layer, okay, of the system what we are talking. Okay. Then from there what we have is called as the conceptual schema. Okay. So, what happens is each external view is created or the creation is facilitated using the conceptual schema. Okay. And then from the conceptual schema you have something called as the internal schema. Okay. And then in the under the internal schema you have so you have stored database in computer. Okay. So, you have multiple databases that you are storing. It is also possible like this as well. Okay. It is all over the place. Okay. You can store all over. Okay. Makes sense. Now, this conceptual schema and internal schema, there is a mapping as well. So, this conceptual schema is at the conceptual level or layer, okay, and the internal schema is at the internal level or layer. Okay. Now, this transition we call it as the external conceptual mapping, okay, and this is known as the conceptual internal mapping. Okay. So, the translation from the external layer whatever the end user sees. Okay. So, the end user mostly will be what we call as using a computer, right. So, the end user will be using a computer or a display device to see an external view how he or she perceives the data. That is translated to a conceptual level where there is a conceptual schema. Okay. So, that contains the, so we already told what is a conceptual schema, and the conceptual schema is more like the high level semantic entity based model. So, okay. So, this is the perception of the designer. So, this is where the database designer comes into picture. Okay. The perception of the mental model. Okay. It can be captured in the relation database system. Management systems allow you mechanisms to capture that, and from there the internal schema, that means it is dependent on the computer plus operating system plus DBMS, the relation database management system, whatever be the that particular choice that you have, that translates this into, and then this happens in the level of hard disks, otherwise non volatile storage. It can be a solid state devices, SSD, whatever you want to call it. So, some way of permanent storage is what we talk about at this point. Okay. So, this is the typical 3 schema architecture that is followed in the decision support system. Okay. So, now let us talk about little bit of the DBMS languages, okay, the major DBMS language that we use in the system, and there are so many of them, but we are only talking about the most important, not so many, there are many of them, most important and relevant to DSS. Okay. So many, but let us just define with these 4. Okay. So, the first thing that we are going to deal with is data definition language, also known as the DDL, okay, data definition language. So, what is it? Okay. This specify the conceptual schema, conceptual schema. Okay. So, this DDL allows, okay, it provides means constructs to capture, okay, user or users concept. Okay. So, the DDL is the language that allows you, provides you means to capture this. Okay. Also remember this, certain databases also use DDL to specify external and internal schemas. Okay. So, remember this is an important aspect. I mean, there are certain databases, both external and internal schemas. So, remember this, the external and internal schemas are all DDL can, certain cases can also be used to, certain database systems can use DDL to specify this. Okay. So, keep that in mind. Then comes the second one, which we call as the storage definition language, SDL. Okay. So, the main purpose of it is the specify internal schema. Okay. So, if SDL is used, okay, then it is mostly for internal schema or how the internal storage happens. Okay. So, in a case, as I said earlier, certain cases this internal schema and external schema, certain DBMS uses DDL, but if somebody uses SDL, okay, so mostly the storage definition language works in this internal schema aspect, right. If you are using SDL, then mostly DDL is defines with the external or conceptual aspect of it, right. Then there is a third type of a language which is called as view definition language. So, these are all languages that are all mostly associated with what we call as the RDBMS. Okay. This again discussing on relational database, DBMS. Okay. We are talking about the relational database management system. Okay. So, the view definition language, the purpose is specify external schema, okay, is dedicated. Okay. So, then what happens is, if you look into this diagram, the VDL, the view definition language, is associated exactly with the external. So, if somebody is using VDL and SDL, then the DDL remains in the conceptual schema format, but certain database systems DDL can also be here. Okay. So, certain languages or database management systems use DDL throughout. Certain cases they have DDL for the conceptual, VDL for the view definition language for the external, and storage definition language for the internal schema. Okay. If that is the case, then there comes the last one, which is called as a DML, data manipulation language. Okay. So, this is a tricky one. So, we have already cleared it up. So, where is this DDL? What is the concept? Sorry, DML. Where is the space for DML? So, DML is to, what it does is it specify database updates and retrievals. Updates and retrieval. Okay. So, how do you update the data or how do you retrieve the stuff? It is basically driven by DML, data manipulation language. Okay. So, you have to think about two subparts of it. Okay. Number one is the data sub language. Okay. This is embedded in general programming language. Okay. So, for each programming language, when we talk about a specific programming language, let us say C, C++, Fortran, Python, Perl, PHP, whatever the programming language, then the data sublanguage means whatever the specific sublanguage associated with that programming language to do. What the purpose of it is? What to do? The purpose is to do data manipulation. And what is data manipulation? Data manipulation is updates and retrieval of the data. Okay. The purpose is to do data manipulation. The other option, second option of it is standalone data manipulation language. Okay. This most of the time is also known as the query language. Okay. So, when somebody says SQL or something, structured query language or something, when somebody says you heard the word query language, that means it is a standalone data manipulation language. Okay. So, in a way to think about is query language is a standalone data manipulation language. That is something that you should realize. So, if you are using a construct of C, C++ or Python or something like that, that is okay. Then that will come in the data sub language, which is embedded, which is clearly associated with a programming language. So, each time you learn a programming language, you have to learn its associated data sub language. Otherwise, if you learn a SQL, which is standalone, which is independent of any programming language, then you learn SQL, and then that allows you, that gives you ways and means to deal with the you can update and retrieve the information data from the database. Okay. Hopefully, this is clear to you. And remember, this is the 3 schema architecture and how the various DBMS languages find applications in that area is what we discussed. Then there is another type, okay, DBMS language. We talked about the 4 types of DBMS language here as the DDL, SDL, VDL, DML. So, there is another classification. Okay. This is more from the usage dimension or angle. Okay. Again related to the DSS. So, the first one is called high level language, okay, or high level DBMS language. Okay. They are also known as, there are other names for it, also known as non-procedural, okay, or declarative languages. Okay. So, somebody says non-procedural or declarative or high level language, we are talking about the same. Okay. Example, what the main example for is SQL, okay, stands for structured query language. Okay. So, structured query language, as I said earlier, it is a data manipulation language, it is a standalone data manipulation language. Okay. So, what is the important thing? Okay. These DBMS languages are set oriented. Okay. It is oriented towards a set. Okay. Set means you remember what a set is. Set A is equal to, it is a collection of, so something like this. This is a numerical set and stuff like this. A set oriented language that specify, what does it do? It specify what data to be retrieved and how to retrieve. Okay, both aspects. It specify what is the data that need to be retrieved and how do you want that data to be retrieved from the database. So, that things, all those aspects is what it comes in part of the high level language. Okay. Then comes what we call as the low level language. Okay. These are also known as procedural languages. Okay. The other one is a non-procedural language, this is called as a procedural language. Okay. There are not other names as of now for it. Okay. What do they do? Okay. There are certain aspects to them. They specify one record at a time. So, remember major difference is the other one is a set. Okay. This is set oriented. So, it retrieves the entire set of data, but here it receives only one record at a time. Okay. Also specify how to retrieve the data. Okay. Okay. But this how is further. Okay. Also includes the constraints and associated loops. Okay. So, it tells you what are the constraints and associated for loop, a while loop, do while loop, whatever it is. Whereas, the other one, because you are retrieving a set, okay, it tells what data is to be and how to retrieve the data, but no need to specify constraints and loops. Okay. So, that is not there. Okay. So, this way the high level languages are much more easy for the human being or the programmer, whereas low level language you have to pretty much deal with everything. The reason why you go with a low level language is because it is quick and faster compared to the high level language. The computing overheads are low. So, that is one of the reasons why people prefer high level. If anybody uses low level language, that is to expedite or speed up the process. Okay. So, that pretty much finishes off our current lecture, the basics of the relation database. Before we get into what we call as how do we do the conceptual design of a database, which is the next part of the course. And then from there we will go all the way up to ER diagram and how to create an ER diagram. And then after that we will learn a little quickly how to translate ER diagram to be a schema diagram. And then we will look into what we call as database normalizations quickly, not all aspects, relevant aspects of normalization. And then once it is done, we will learn a little bit of SQL quickly, how to create a table, load the table with the data, manipulate the table. And then I will give you a brief primer of what is big data, and then we will stop there for the other instructor to come forward and give you other information about it. So, once these fundamentals are clear to you, then the advanced aspects of managing the database is not a big deal. So, thank you very much for your patient hearing, and we will continue more topics about the database in the next coming class. Thank you very much.